Hello and welcome to this video on the practice questions of equations of motion, AS physics, SUVAT equations. So here is your question right in front of you. It is a short question, fits in one screen. If you want, you can pause the screen, try to attempt the question yourself, and then play the video again to look at the working, look at how I work on this and compare it with your working. And you can also, I'll also show you the mark scheme as well. So hit the pause button. And in the meantime, do not forget to please subscribe to the channel if you're finding the videos really helpful for you to prepare for your exams. If the videos are helping you to score good, it is a proud thing for me. Let me know in the comment boxes. It will be really appreciated for me. Alright, so I assume that you all have paused the screen and now ready to play the video and look at the working of it. Let us understand what the question is telling us. A ball is thrown vertically down towards the ground with an initial velocity of 4.23 meters per second. The ball falls for a time of 1.51 seconds before hitting the ground. Air resistance is negligible. Let us draw a picture of it. It is always a good idea to draw a rough scale of what is happening in the question. So let us take a ball. So you have a ball. So the ball is thrown vertically. It is not dropped. The ball is not dropped from rest. Say that somebody is holding this ball and this person who was holding the ball, he has pushed or smashed the ball down towards the ground. At what velocity? At a velocity of 4.23 meters per second. Let us draw the ground level as well. So here you have the ground. Alright. So what is happening? The ball falls for a time of 1.51 seconds before hitting the ground. So the time taken for the ball to reach the ground ultimately is how much? Time taken to reach the ground is 1.51 seconds. This is the total time taken to reach the ground. Air resistance they are saying as negligible, which means that the acceleration will be g. Air resistance being negligible, you should always assume it means that there is no other force acting on the ball other than the force of gravity. So acceleration is g. Part A. The first part. Show that the downward velocity of the ball when it hits the ground is 19 meters per second. So they are telling you to find the final velocity. So let us write down the data that you have. Initial velocity is given to you. Initially it starts with a velocity of 4.23 meters per second. Time for the fall is also given to you, 1.51. And you also know the value of A. A is g, which is 9.81 meters per second square. This is in seconds. Alright, so what do you have to find? You have to find the final velocity. Which formula makes sense here? Which formula? Let us see which formula. There are so many, I think, one or a couple of formulas you can apply here. Let us look at the list of the formulas here. The first formula directly makes sense because you know T, you know A, you know U, you can find the final velocity. Second formula, no, because you do not know this variable. Third formula also because you do not know this variable. Second and the third formula doesn't make sense. And the last formula, does it make sense? No, even the last formula doesn't make sense because you have a variable S which you do not know, right? So the first formula makes sense, which is same as the formula for acceleration. A is equal to V minus U over T. Both the formulas that you see here, they're precisely the same thing. So if you find it difficult to remember the first formula, though these formulas will be given in your question paper, but for handiness purpose, if you do not remember the first formula, you always remember the acceleration formula which you can use here. Or you can straight away say V is equal to U plus AT. So let us use this formula. V is equal to u plus at. You know the value of u, substitute all the values in the equation. 4.23 plus a is 9.81 times 1.51. Now a is positive. Why? Because the ball is moving downwards and g is also downwards. Both of them are in the same direction. The ball is moving downwards, even the g is downwards. Both of them are downwards, same direction, so a will be taken as a positive number. Solve this out in your calculator. I'll show you the mark scheme now. Let me show you the mark scheme now to tell you your answer. Let's see how they are doing this question. Yes, they have also used the same formula, and the answer is this, 19.04, right? You can also write your answer as 19, that's allowed. Allow the use of, you can use g as or a as 9.8 or 9.81, that's also allowed. Alright, so that's how you do it. If you want, you can pause the screen here and refer the mark scheme properly. So your answer should be 19 meters per second. It's a 2-mark question. You get one of the marks for writing the formula correctly, even if you do not substitute the values and get a wrong answer. Even if you are getting the wrong answer, at least you will get 1 mark for writing the formula correctly. So it's always a good idea that you write the formulas at least before you start solving the question. Now the second part, calculate to 3 significant figures the distance the ball falls to the ground. You have to calculate this distance. So if you have to calculate this distance, look at the values that you know. You know u, you know t, you know g, you know v. Now you know v as well. So many details are already given. So which of the formula makes sense? Let us look at the list of the formulas. Which formula do you think makes sense? You have s here. You can use this formula. You know u, v, t, every t as well, you know, right? You can use the second formula as well. You can use the third formula as well. You can use any of these formulas. Believe me, trust me. You can try working with any of the formulas. You will ultimately get the same answer. Right? So one of the most commonly used formula for finding the distance or displacement is this one. So let us use this formula, though it is slightly complicated as compared to the second one, but let's still go with equation number 3. So S is ut plus half at square. You know, substitute the value please. T you know, half at square. Please solve it in your calculator, substitute the values, pause the video for a moment here and work out your answer. I'll show you the mark scheme now. If you want, you can pause, work it out and then play the video. So here is your mark scheme. The mark scheme also suggests that either you can use this formula or you can use this formula. Your answer should be 17.6 or 17.5, right? And the G value should not be taken as negative here. Why? Because we are traveling the displacement from the first position to the last position. For displacement as well, you are traveling from this point to this point, which is same as the direction of G. So do not take G as negative here. The answer should be, let me show you the answer, 17.6. Alright, unit is already given, so you need not worry about it. 2-mark question, you get your full 2 marks. Do not forget to write the formula. To be assured, if you write the formula, you can be assured that at least 1 mark you'll definitely get, even if your calculations go wrong. Now the second part, the ball makes contact with the ground for a very small portion of time, which is 12.5. Look carefully, it is milliseconds, ms. and rebounds with an upward velocity of 18.6 meters per second. The mass of the ball is given to you. Calculate the average force exerted on the mass on the ball on impact with the ground. So what is happening? The ball is coming, it hits the ground and it rebounds, right? This is what is happening. The ball is starting from the topmost position, it reaches the ground and it rebounds. So what is the rebounding velocity? The rebounding velocity is given to you. It rebounds here with the velocity of rebound velocity is how much? 18.6. It is in the upward direction. Rebounding velocity will be in the upward direction. Calculate the average force exerted. Force exerted. So which formula do you think makes sense here? Which formula for the calculation of force? It's the same formula that you are aware of. Force is equal to ma. A is what? V minus u over T, which is same as mv minus mu over time. What is happening? The change of momentum. What are we doing here in the numerator? It is mv minus mu is change of momentum per unit time. That's one way of saying it, or you can calculate the acceleration separately and multiply it with the mass. It's the same thing. It's the same thing. Let us substitute the values now. Let us start by taking one of the directions as positive direction. Let us say because we have been working with the downward direction as positive, let us say that the down direction is positive. Anything which is going down is positive. So when the ball is hitting the ground with the downward velocity of 19 meters per second, it is a positive velocity. And when it is rebounding and going up, the upward velocity of 18.6 is a negative velocity, because rebounding velocity, this is an upward going velocity. So we'll be taking it as negative sign and this as a positive sign. Why? Because we are taking everything which is going down as positive. So before you start attempting the question, you should decide and fix upon which direction you are taking as positive. Since in the initial part of the question we took everything which is going down as positive, so V, initial calculation of V, the hitting velocity 19 will be positive, upward going velocity rebounding will be negative. Let us now substitute the values. What is the mass? Let us use this one because this looks quite easy, right? For the moment I am not using this one. Mass is how much? 46.5. What is the rebounding final velocity? Final velocity is the rebounding velocity. Let me write it down. The velocity which happens later, it is negative 18.6, and the initial velocity was the hitting velocity which was going down 19 meters per second. Substitute everything with proper usage of the sign. Minus 18.6 minus 19 over the time taken 12.5 times 10 to the power minus 3. Solve it in your calculators, please. All of you. You should see that your answer will be negative. Whatever answer that you'll get for the magnitude of the force, because I already see so many minus signs here, your answer will be negative. Negative means that the force is in what direction? Down we know is positive. If the force is negative, it means that the resultant force is in the upward direction. What is the direction of the force? Up. Because up direction is negative, your answer is coming out to be negative. So what is the magnitude of the force? Work it out in your calculator. Pause here for a moment and then I'll show you the mark scheme. So here is the mark scheme. Let's see, are they also doing the same thing? Yes, they have done the same thing. Do not worry, they have taken both as positive. Why? Maybe they took the upward direction as positive. That's why everything is positive here. Do not worry. Our working is exactly opposite, but it is correct. Believe me, it is correct. Right? Here the magnitude of the force is 140. Your magnitude, as we are doing, will be minus 140. And the direction is upward. So the answer should be 140. It's the same thing, only thing that we have worked the other way around. Minus 140 newtons. No worries, do not ignore the sign. It depends on which direction you are taking as positive. Your answer will be negative or positive. Do not worry, it's perfectly fine. And the direction of the force is upward. Alright. If you have questions, concerns, type in the comment box. We'll chat one-on-one and I'll explain your doubts to you. Next part, use the conservation of energy to determine the maximum height the ball reaches after it hits the ground. Conservation of energy, how do you use? The most simplest form. Kinetic energy at the beginning, at this point, when the ball has hit. Kinetic energy when the ball hits, the kinetic energy when the ball hits is same as, it's same as the potential energy at the topmost point. Will be equal to potential energy. So half mv square is equal to mgh. So they are saying maximum height, m and m you can strike from the both sides. So h will be half v square over g. So what is v here? V is the rebounding velocity of 18.6. So substitute the values. Half 18.6 square over 9.8. Solve it in your calculators. This will give you the height. And what should be the answer? Pause the screen for a moment here. Work it out on your calculators and see if you're getting the answer correctly. I am now showing the mark scheme. See, same thing they have done. 17.6. 17.6. State and explain whether the collision the ball makes with the ground is elastic or inelastic. Is it elastic or inelastic? Go through the theory about elasticity and non-elasticity. It relates with the kinetic energy. Is the kinetic energy before same as the kinetic energy after? Ball is, let us understand. So here you have the ground. Let's roll on. The ball is hitting the ground. The ball is hitting the ground with a velocity of 19 meters per second. We calculated it in the first part, 19 meters per second, and then it is rebounding. It is rebounding at a velocity of 18.6 meters per second. Is there some velocity lost? There is some velocity lost, right? That means there is kinetic energy lost. Initially the kinetic energy was half mass times 19 square mv square. Now the kinetic energy is half mass times 18.6 square. There is a loss in kinetic energy happening. You subtract these two, that's a loss. So because kinetic energy is being lost, it is not conserved, it is not the same, it is a inelastic collision, right? So here it is, the kinetic energy of the ball is not conserved on impact, so therefore it is inelastic. Or you can also say in simple terms that the speed before the impact is not equal to the speed after. Speed is getting reduced, automatically speed links to the kinetic energy, so you can say kinetic energy is getting reduced, so it is inelastic. So here you are, the working of this question number 4. You can have a look at the working, and as well as you can have a look at the mark scheme. If you have further questions, please let me know in the chat box, and your feedbacks are very important. If you liked how I explained this question, please let me know in the comment box, or even if you have some suggestions to improvise, if there is certain thing that you did not understand and if you want me to explain in a certain way that you think would be more comfortable and more relevant to the students, please do feel free to let me know. Alright, so with this we end this video. In the next video, please find the next question on SUVAT equations of motion. Thank you. Have a nice day.